Hello again, everyone. I hope you can hear me well. So today we will be doing Java technologies again. And so after the holidays, we have to finish the design patterns slide set. So I hope you are excited to finish it up because it contains lots of patterns and we have to go them one by one. So basically, let me share the screen. I'm just closing various systems here. Okay, desktop. This one share. Okay, so as well, you have already submitted one of the tasks. Let me open. Okay, most of you are connected. Yeah, most of you did. Okay, so basically, we have already finished one of the milestones. With what comes for the hands-on tasks. So basically, hands-on for the task one you've already submitted. I've checked; most of them were okay, and you have got 2 points as it was specified over here in the evaluation. And just a reminder of you who have not submitted them or who have got response that something is wrong, you have to do that anyways because this task is mandatory for the exam allowance, right? As it said here, task 01 is mandatory to be allowed to exam, right? So until the end of the semester, you have to submit this task anyways. Okay, so basically, if you will do that, so you will be allowed to exam, but after the deadline, you will not score any point. I think there are still 3 projects that I have questions for, so please respond. Actually, yesterday we have solved one just after the lecture in Microsoft Teams talking about the things, and we were able to solve one of the questions regarding the not working tests. Okay, so basically now I'm moving to the presentation part. Last lecture we talked about the design patterns. This is basically organization of various classes within the application. And it is needed because certain problems appear all over again and again and again in applications. So basically, to solve them, designers, developers implement various patterns. They name things in a certain way. And this is very common in various frameworks. In this case, we're talking about object-oriented framework, where we have classes, objects, or instances. We organize them, we aggregate, we extend, we interface, and things like that. So since there are lots of structural elements of different kinds, there are certain patterns, there are certain class organizations that are being repeated again and again. So for these things, we have design patterns and we basically replicate these throughout the system. So basically, so far we were looking into the Django 4 classical patterns, which are coming from the 3 groups: creational, structural, and behavioral. Right. So we have looked at the creational and structural. So what's left for us is to look at the behavioral patterns, right? So we looked into these, into flyweights, proxies. Okay, let me run through quickly. So basically, for the creational ones, we have patterns for building up instances of classes. So again, this is for decoupling different parts of applications. right? So basically producing objects from the actual production, right, can be separated by using a bunch of factories. Then the builder building parts can build a sophisticated part, including a nut. So basically modification of the building process. Then factory method, where we can have certain applications extended in a building, overridden. Then the prototypes, so basically cloning stuff. Singletons, this is, the single instance allowed in the virtual machine in Java. Okay, so adapters, adapting pieces of application that do not talk to each other via intermediate object. Then the bridge, so basically connecting two hierarchies together by connecting them, basically aggregating on the upper level, right? And then composite, this is basically a tree hierarchy. Then the decorator, this is basically adding behavior state to the components which are included inside. The facade, this is a class which basically represents functionality coming from many different classes. Flyweight, producing objects which are simple a lot, so we don't need to create them. We just basically can take use of the cache. Proxies, this is basically lazy implementation possibility. So you can basically pretend of having all the resources already, but you would not, and you basically would have them only on the first usage. And now we have come to the behavioral patterns. This is the last group in the gang of 4 patterns. Okay, so basically behavioral patterns are meant for change the state or behavior of the information flow in the system, right? So basically these patterns optimize how flow or how behavior or state are being transformed and modified in the application. Right. So again, all these patterns are meant for decoupling pieces of application, allowing to extend it without extensive reprogramming of the application. Right. So we have a bunch of patterns here, and we will be looking into examples as well as the UML diagram. Okay. So here the first one is the chain of responsibility. So what chain of responsibility does, when the client wants to issue an operation, runtime, you can define the set of operations in a sequence that can be done runtime, so basically dynamically. So basically, when you have a command handler that does some simple job, simple or not simple, it just basically depends on application. But when this class produces some kind of product that does the job, right, it can have multiple steps, and these steps can be arranged in the sequence. So basically, you call this guy, the command handler, to do something. It does the thing, and then it can call the other step, and the other step, and the other step. So all these steps, all the job, just like in the factory, can be done in multiple steps. The configuration of steps obviously can be defined runtime, right? So basically, the idea is such: if you have a factory which is producing a car, for instance, right? At first, what you do, you just basically put the body of the car, right? Then you paint the body of the car. Then you put the engine, seats, wheels, and then basically decal, and then you ship it. So if you have the factory of all these steps here, so you can arrange them in a sequence. And once you call produce a car, basically this sequence is being called. So maybe, for instance, for some car, you don't need an, let's say, engine, right? So basically, you can define which kind of engine you need. So for instance, you are producing Volkswagen Golf, right? And at some point you just say, okay, I just now want to produce it in electric version, right? This will be my electric vehicle, right? So basically I just change one step, right, to just plug in the electric engine installation, and the chain works just like it did. And this can be done a runtime. So basically I can extend the command handlers as much as I want. Okay, so this is basically the chain of responsibility, which makes it possible to run multiple steps of some action in the in some sequence. So basically, chain of responsibility example, which I have here, it basically shows that the commonly used pattern in Java, then the logger is basically assigned in a sequence of various loggers, right? Of various loggers runtime. So here, for instance, we have a root logger, right, which is a console logger, and we just say, so after this console logger has been called, let's call the next logger, right, and this is a file logger, right? So basically we have arranged the logger in a sequence. If we would look into the logger, right, into the logger definition, we see that this logger has the possibility to accept other loggers inside. And once you call the command log message, right, it just basically does its job, right? This is logger's job to do something. And then it passes the same arguments for the next logger. And this chain is constructed on the runtime, right? So basically runtime, you construct the chain by creating more and more loggers, right? So basically, if you run the file, you will see that this message, right, some error message, some info message, some debug message is being passed from the console to the file, right? And this is to the file. So basically, this specification of what here So basically, the specific loggers, like the console logger here, is simple, right? What it does, it just extends the logger, right? And it knows how to write the message. That's it. Everything else is handled by this super type. Just like the file logger is simple as well. It just knows how to write the message, nothing else. It just handles a very specific piece of work, but the chain itself is handled by the super type. Okay, so I think you've got an idea. So basically, this is what we have. We have a logger here. All the logics in handling the chain is encompassed into this class, right? And these guys are just simple guys. We just know how to handle a request or print a log. That's it. Okay, so basically runtime, you define the sequence of actions that you want this guy to be used. Okay, the other one is a command. So this command is basically when you want to decouple and you want to extend the commands that you're about to use, right? So for instance, you have a client, you have some guy which is capable of executing something, right? And the command, the type of the actual execution is dedicated for the other class, right? So we basically have abstract command, we have abstract execute method, right? And we have very specific commands. So which one is actually executed, it is defined runtime, because on runtime, we say which one is to be passed for the invoker, right? For the guy who's able to execute it. So client, by definition, does not know which command to execute, but the runtime, it is defined by the command object, which is being passed to the client. Okay, again, into the example. So command extended example. Let's see it. Okay. Okay, so we have a broker, and broker is invoker, right? So what broker is capable of, it can receive orders, right? Receive orders and execute them, right? So basically execute orders is going through the orders and execution of them, right? So basically what kind of orders, broker does not care, right? It places it into the chain, and once by the scheduler execute orders has been pressed, it basically executes them. Now the actual orders themselves, right? Abstract. This is an abstract command which is capable of. And these ones by stock, right? So this is the stock. Basically, by stock, what it does, it specific on the buying or selling, right? And you have specific guys buy and sell stock. Then, so this is basically on the execution, right? So started developing it, so you can easily extend number of commands, right, of stock orders, right? Of orders, right? So basically, this is only buying functionalities. For instance, hold, right? Sell if a certain condition, and so on and so forth. And your application independently from the broker and the actual stock exchange, right? So for instance, run file, we just run it, and let's see, yeah. So Nasdaq Vilnius, this was the stock exchange, has of Telia now, right? And this, right? So basically, it's not anymore. Okay, and Nasdaq Vilnius about Telia again.
Mes beveik nieko negirdim.
Negirdit?
Negirdim, labai blogas signalas, va pažiūrėkite čatą. Jau 3 ar 5 minutės. Nieko negalim suprasti.
Geras, kodėl taip?
Gal kažkoks triukšmas yra, nežinau.
Very bad signal. Aha. Ok. Bet dabar kažkaip tai gerai atrodo, ne? Ar blogai?
Dabar geriau.
Dabar geriau? Jo, nu, ką žinau, nieko negaliu padaryti daugiau. Šiaip tai šiandien iš viso trakinėja šitas ryšys, nežinau, pas mus kažkodėl taip jau gaunasi.
Gal kai jūs rodot slaidą, tada daugiau informacijos bando praeiti per kanalą ir pradeda lagai, nežinau, va dabar viskas tvarkoja.
Dabar gerai, ne? Tai gal man nemaksimizuoti tiesiog šitą daiktą?
O va dabar vėl prasideda.
Vėl prasideda?
A,
Vienas, 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 vienas.
ne, dabar gerai. Nu, nežinau. Keista.
Žinot, ką galim padaryti? Aš galiu pabandyti perskrauti kompą, nes jis nebuvo krautas jau labai ilgai. Aš pabandysiu iš naujo prisijungti. Gerai, jūs palaukit.
Gerai, palauksim.
Just wait a little bit. I will reconnect. Okay, myself. So basically, hang up. Okay, bandau grįžti. Kaip girdisi dabar?
Garsas nelabai geras, bet bent jau nelagas. Turėtų pasitaisyti garsas.
Kaip sakyti? Gerai ar ne?
Gerai kažkas.
So far so good. Okay, so let's continue. It's recording. Yeah. Share screen. Okay, let's try to share now. Maybe it will change. Actually, my kid was complaining about VNetwork today while playing at Minecraft. So, yeah. This happens when you have 5 people in the house, and 3 school kids and 2 adults working remotely. So this sometimes happens that networks not behaving very well. Okay, If something goes wrong again, please say me by voice. All right, so let me launch examples again. So I guess you have got an idea about the command, should not be wasting more time on this. Right, so again, decoupling the commands from the execution and the extension for the number of commands. Okay, this guy. Source files and behavioral guys. Okay. Okay, so next one is the interpreter, I guess. Yeah, interpreter. So basically, we have looked into the interpreter already a week ago, and I hope you already started working on this in the task 2. So hopefully everything is fine. If you will have any questions, let me know. But if you would use it correctly, it should be quite simple to implement with task 2. So, okay, I'm going forward. The next one, the next slide is about, I will try to make it full screen, we'll see. So basically, the next slide is about the iterator pattern. So iterator, this is some consistent way for sequentially accessing items in the collection. And this basically creates an independent from the collection itself. This is a collection, right? This is a collection that has many items to iterate at. And once client calls the iterator, iterator is being created. That's separate from the collection itself. And basically by calling next, 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 has next, you can receive these items in a sequence. And basically iterator is a one-time object where you can loop over, right? You can iterate over and then you just drop it off. It's not being reused anymore. Right, so this is an iterator example, which I have, a homemade. So basically we have an iterator interface and we have an aggregator interface. This is a generic aggregator which accepts a bunch of values just for illustration, right? And it stores inside. This is an array. And once an iterator is called, iterator method is called, it initializes the new object of iterator, right? It has internal I pointer, which points to the next value, to the current value, right? Has next, it just tells that, yes, I have next, until the end. And the next, it basically takes value and returns. As well, what it does, it increments the pointer, right? It moves pointer up, right? So this is basically the iterator. That's an example. We have a generic aggregator like a collection. And from this collection, we take this iterator and we loop over it, right? Has next, and printing out. Run file. So once you have used the iterator, right, ran to the end, all the items have been used. So you basically dump it off because you can't, by the classical approach, you just can't reuse it anymore. Obviously, iterators are used throughout the system. Right, in Java, we have iterable, right, iterable thing. So again, this is the Java collection, homemade, and then this is the iterable, right, the Java util iterator, which has next and next. So basically the same business, but the interface is taken from the Java API. Okay, so I think you understand this guy, and this is nothing special, but since it's coming from the classical patterns, why not talk about this? Okay. So next guy is the mediator. this is mediator. This is an object or pattern which basically simplifies the communication among objects in the system, where we have an intermediate object for message distribution. All right, so basically we have many colleagues. This is a hierarchy, and these colleagues are talking between each other, right? We are changing messages. So on the abstract side of these colleagues, in the super level, we just create an intermediate object which passes messages, right, between the colleagues, right? So basically this pattern allows you to extend number of colleagues, and once you will add these in a hierarchy, they will get this super type capability of exchanging messages between each other, right? This is like a chat box. So mediator demo, we have a mediator where we can add a colleague, a new guy on a block who will be changing the messages, and there is a send message. This is a message, and this is the guy which is actually sending the message, right? So this is a colleague coming. These names are coming from the classical pattern. So basically we have colleagues, right? Obviously we need to pass the mediator inside. So this is an object which is being used for message exchange. All right, and we have a bunch of colleagues. In an example, we have a desktop colleague which has to implement the constructor and the receival of messages, right? So basically this is a receival of messages, because you need to react somehow once the message was arrived from the other colleague, right? This is a simple mediator which has a list of colleagues right inside. Okay, and while sending it basically iterates over these guys. So this is an example where we have initialization of a mediator, when we have a bunch of colleagues, and these colleagues are sending messages between themselves, right, through a super type run file. Okay, so this is, this basically all these colleagues are basically receiving the message and talking to each other. So Windows at desktop, Mac, I'm the best, right? So Windows is claiming that it's the best, right? Mobile Mac, and Linux is telling that I'm free, right? And so on. So all these guys are coming from a different flavor of the system, actually talking to each other. Okay. No messages, no, so far so good. Okay, so this was mediator pattern. Okay, so this is a strange pattern which worth mentioning, which is a memento. I think this is more or less an over-engineering of the object orientation, which was very common in the beginning, in the advent of the object-oriented programming, because people are tried to use in object orientation in various strange ways. So memento is basically a possibility to store the state of the object, and the state would not be possible to reveal to the other objects, right? So basically you have the originator here, right? But this is an object which is actually acting in a system. And once this object is wants to save its state, right? Basically save the fields, it can create a memento. And this memento is accessible and readable only from within the originator. And this memento, this state can be stored in some other objects, like here, right? It's basically stored in some other object which cannot read that, right? It cannot read that state. It cannot alter the state, right? And once we this object, initial object, wants to restore its state, something like we undo, this caretaker basically gives the state back. So all this trick is regarding the hiding the state and not allowing to alter it from the external objects. Okay, so this is an example. Let's take into Memento example. Okay, this is the text file. This is the text file, and it has a state, and the state consists of the title and data, right? This is text file title and text file content. Okay, so we can get title, we can set title, right? So basically change the title. So this is mutable object. We can add some contents, right? We can get the data back. Okay, so these are all just altering states for the object. Okay, and then we can call this save, right? Save, so basically get the current state of an object. And what it does, it returns a memento for us, right? Memento. And this is basically the storage of the state. And as you can see, what it does, it creates new memento where this object is being passed, right? So basically, and memento by itself is the private class inside this object, right? So this is a nested class inside this class, and it has private fields which are being filled right here in the constructor. Okay, so obviously this class can be accessed from within the text file only. No other guys can access it because it does not have any getters. This is a private class. It has private fields. So basically no other object in the Java virtual machine, by following the normal rules, can access the state or alter the state. So once basically you want to read the state back, you just basically call undo and pass an object, and this object must be memento, so you can read it back. So this is the whole trick, right? The trick is that you initialize the internal nested object, which has a state readable from only this nesting class, right? So this is the caretaker by following the classical pattern notation, right? Which has the save call. So it basically calls database save and stores the state in an object. And if you want to undo, you just basically undo, call the undo. So this is the example. So we have initialized the textual file, we're adding a title, we're adding some contents and printing it out, right? And then we have a caretaker, which will store the state of a file, cannot modify it. We do the updates, and then we basically restore, right? So basically, let's see it working. Run file. Okay, so this is what we've got. So this was an initial state, right? Where we had data text, when we have some data again passed by. Then we have made, oh my God, exec, right? So basically we have altered it, the state, right? And then we restored it back. So basically the trick was that this caretaker was holding the state of this text file, and once it was needed to restore it back, to undo the changes, it basically passed it back. And the point is that the state was not readable, not updatable by anybody else, only from within this class. Okay, so as I'm telling you, this is a little bit over engineering, because why in a world you would like to do this? Why in the world you would like to store that within the application? But who knows? This was an idea how we can use the object-oriented programming languages and store states not allowed to modify for outside objects. So a little bit of overprotection. Now developers do not care that much about this kind of behaviors, right? Okay. The other pattern, which is more frequently used, quite frequently actually used, this is an observer pattern, behavioral pattern of an observer, where a way for a component broadcast of messages is being provided, right? So the interested receivers receive messages once the state is being updated, right? So we have a subject which updates a state, and we just basically assign an observer which is notified once the state was changed. So this is very common when programming the UI, right? So all the UI, all the visual elements in the system like this, like I'm showing right now, is being constructed in a hierarchical way, right? We have the main window. This main window has a title. Then this title has a font, right? So then we have the main frame. This frame has a visual elements, have a ruler like here, right? Then we have a slide and so on and so forth. So then each change of the super type of the enclosing element, right? Like a window, for instance, right? When I modify the window, it propagates the change to the child elements, right? So basically, for instance, resize of this window, it basically propagates the state change of width and height to all the elements inside, right? So basically, we can tell that this window is the subject, and observers are all the other guys which are related to that window. Right, so this is very, very frequently used. Sometimes this is not an observer call. Sometimes this is called as a listener object. Okay, so this is observer demo. We have a subject. So each subject might have a bunch of the observers attached. So we basically attached and detached observer. And once we get an update, right? So we basically have a method to notify observers, right? So this is a generic class of subjects. So for instance, this could be in the GUI, this could be a widget, right? So each widget can have other widgets inside, and all the widgets are basically can notify children. Okay, so this is a specific subject which we call a topic, and this topic has a title, and once the title is being changed, right, we not notify observers, right? Okay, and this is the observer, right? This is the observer. It gets an update when something happens. Okay, topic observer. This is a specific observer which gets notified. Then the subject has changed, something like this. So we have a topic, right? And we have 3 observers, and we attached these observers to the topic. Right, and then we change the title and we think that these observers are being notified, right? Yeah, so basically in many systems, this is not observer call, these are called listeners, which listen to some event happening in the topic. Okay, so and this was an implementation, home implementation, homebrew method, and this is the observable coming from Java util, right? So Java util API has an observable interface, so super abstract class, right? Abstract class, so basically you can utilize it for your projects as well, right? So it does just the same thing. Okay. So this was an observer pattern. I hope it's understandable. Okay, state. So state basically when our system can get into bunch of states. Let me present into the bunch of states. So basically we can define these states. We can decouple these states from the actual application by this interface and extend them. So basically we can add more states to the application once we develop it, right? And each state can have a certain behavior. For instance, it can has some handle, some fields, and so on, right? So this is the state into which application gets at, right? Okay. So basically nothing special. Usually we encode states as, for instance, a numerator or something like that. But you can extend this and you can have multiple states as a separate class. And then you can basically include more functionality or more information into these states. So for instance, here we have the state, right, that has some functionality to do action. And we have a couple of states. One state is on, another state is off, right? And an action is running. Some other action just says an idle. Okay, so we have a washing machine, right, which implements a state. Implement state. Why it implements a state? It should not be implementing a state, I think, or maybe implements a state because it receives a state. It has a state inside, right? It can change the state, and then on action, it can just do an action, right? I don't know why it implements a state. Okay, so now basically we have a couple of states on and off. We have a washing machine, right? The washing machine, in the beginning, it receives a state off, right? And do action just does nothing. And once we change the state on do action, it will be running, right? So something like that. And we can add additional state, for instance, a state broken, right? Not running anymore. So then basically all the actions would be not washing, right? Bring me to the repair shop or something like that. So this is the whole idea that you can have actions and fields assigned to the state, and then you can extend these states, the list of states, as you go. Okay, and the strategy. So basically, the strategy is a simple design pattern which is used all over in the systems, even you don't know that this pattern exists. Right, so it basically defines a group of classes that represent a set of possible behaviors, and when you pass it to some strategy context, it basically calls the algorithm. So nothing special here. Then you want to extend many different options have for your context, for your execution. You basically have it as a separate hierarchy of classes implemented, right? So this is being used all over in systems. This is nothing so special. Yeah, so for instance, when you have a payment, right? When you have a payment, a certain action in your online shop, right? You have an option to choose a payment. So this is your payment, super type. And this is a specific payment by credit card. Right? And this is how it's handled in some specific ways. You have to provide the number, you have name, expiration year, something like that. And this is payment by using the PayPal, right? This is a different kind of payment. So basically, once you have assembled your shopping cart, you have items in here, right? You have a total price. Then you press the process payment. You just basically provide what you've chosen as a payment. Right? So this is one strategy or the other. So sometimes you can use this shopping cart for paying with credit cards, sometimes with PayPal, etc. So nothing special, but just a separation of the specific task in your system. Okay, so the template is a simple business again. So this is basically subclassing when you need a certain actions to be taken on a different way, on a different course, right? So we have a specific algorithm which does something, right? Which does something useful in your system. It has a method execute, but certain steps are slightly different in a different algorithm implementation, right? So you basically dedicate these steps to the other classes, to the subclasses, and again, you can add some more later on, right? So this is again very, very simple behavior. I think you've used that many times. Okay, so this is an abstract algorithm. This is summator. It is capable of summing, right, and getting average, right? So basically sum and get average. And here, this is the specific method which need to be implemented on a different occasions for reading data, right? And we expect this with read data will provide us an array of integers, right? So what we have different flavors of summators. One summator is capable of reading strings, right? So basically it receives a string and reads it back as a set of integers. Right, and this one is integer summator, which receives readily available integer array and returns it right away. Right, so two different types of summators. So this is the summator list array of summators. So we have string summator, integer summator, and integer summator. And this is just basically application that takes use of these guys. Run file, right? So it basically will sum it up. And nothing special, but just dedication of a certain action to the guy outside of the application itself. Okay, and now we have a visitor. This is the last from the classical patterns. Woo! We're almost through it. Hold on a little bit. So basically, visitor pattern is a specific pattern that provides a maintainable and easy way to represent a complex structure, right? So basically, when we want to visit and to want to work with the very complex structure of elements, so something like this, right? We have an element, this element has some additional elements and so on. So something like, for instance, I've seen this pattern implemented in various grammar parsing applications, for instance, in SQL parsers, in SQL modifiers, in some other programming description languages, etc., etc. So basically, once you have this complex structure and you want to do some actions on the certain elements, what you do, you basically implement a certain visitor. And this visitor makes an action on the certain elements, on the specific elements that you want to. Let's take a look into the example. This is quite commonly used pattern. And from time to time, I actually use it in my applications while developing complex systems. So, for instance, here we have an element, right? In this visible part, we have an element, right? This is the abstract supertype, right? This is the supertype for our elements, right? It has a value, it holds in a value, a final state, right? It has an abstract accept method, right? Accept method. It's capable of returning that value back. Hash code and equals all these utilities, and toString, this is a utility, right? So what it has just an value inside and accept abstract method, which needs to take your attention. Okay, so now we have a couple of elements, specific elements. One of them is a word, another one is a number, right? And so accept, what it does, it accepts a visitor, right? And then it calls for this visitor method visit and passes itself, right? This one does just exactly the same trick, right? And passes itself. So this is an interface of a visitor. This interface of a visitor has a couple of methods, visit word and visit number. So these are specific elements that's about to visit. And here is the implementation of a visitor. This is what I want to actually modify and how I actually want to use this, this specific complex structure. Let's pretend it's complex, right? So this is my count visitor. what it does, I want to count all the words and numbers and put it into a separate numbers, right? So once I visit a word, I just +1 to the words. Once I visit number, I just +1 to the number, right? And at the end, I just want to return these back. This is my specific visitor. Now, this is another example of a visitor, which is more complicated, right? When I want to count the frequency of words and numbers. It has some frequency map implementation. I think it's implemented over somewhere here, yeah. It's a little bit more more elaborated and more complicated example. But what it does on visiting word and on visiting number, it puts them into the different frequency maps, right? And at the end, it has utility to print, to sort, and so on, to make some kind of histograms, whatever, right? But anyway, what this pattern provides an interface for me. And now I'm able to create various different visitors for different reasons, different purposes, right? That can act on the elements, on each element separately. Okay? Sometimes I've seen that this interface is implemented not as an interface, but as an abstract, as a class actually, which can be extended. And by default, these methods are just masked as doing nothing like this, right? So this way, you don't need to implement all these methods, and you can just basically pass them by. For instance, if you are interested only in the number, you just basically implement this guy. Others, you are not interested. And for instance, when you have an SQL parser, you just have so many construction elements like select keyword, right? Then the field names, then various grammar elements, then from, then tables, then where, and so on and so forth. So this is a complicated structure, right? So basically, you will have many visit methods here. And you, for instance, want to modify only one piece of stuff. So this is what you implement. You just act on a certain element. And this is basically our text processor, which makes this visiting possible, right? It accepts some text and then accepts a visitor and then calls this visitor on a certain locations, right? So this is the example application. We have some text. We initialize our count visitor and we call process. And at the end of execution, we just say, this is the number of words we found. This is the number of numbers we found. And for the frequency visitor, we do just exactly the same trick. And at the end, we just print what we have found, what we have encountered. Okay, so running here, and we see what we've got. Words 123, numbers 12, right? So it basically counted all the numbers separated by the space or some punctuation, I think. Okay, and these are basically the frequency map, what we have found. So basically it is a scanning, I guess. These are text frequencies, right? So basically the most frequent was here, the off, right? The off actually 7 times. Here we have off, and for the numbers 10, it is 3 times, right? 3 times, and 1 3 times as well. So something like that might be possible. Okay. Okay, so basically, to conclude, this button allows you to do 2 things. One thing is to maintain the complex structure, right? Complex structure of elements, extend it, add it, and so on. And to have the decoupled visitors, which are basically act on a certain element, then a certain element encountered. Of course, you have to have a parser, etc. So many things are in between, but this basically has a very clear separation over here, one from the other. Woohoo! I'm done with the classical patterns. I hope you enjoyed it. Of course you did not, but that's life. Okay, so now we just have to look into the couple of more patterns. They are not easy to understand, but let's try to do so. Okay, so one of the patterns that I want you to show is the so-called fluent builder pattern. It is very common in dynamic languages like Python and others to use this kind of patterns, where we have a builder, and this builder actually, on the call for the method, returns itself. So you can build an item in one-by-one manner, and then you just basically at the end you call build and return the item itself. So this is a normal builder, but it's organized as a fluent builder, right? So basically, once you try to build it, so you get the builder and new text, you add text, you add actually various elements you want, and at the end you just call build. This one you have to implement in the task 2, I guess, if I remember correctly. Okay, so basically you will encounter that and just know where to look for various examples. Okay, the other very common problem which I want you to show is so-called the dependency problem, because throughout the application, when we build the application and we start grow it from the simple one, the prototype, to the bigger, we encounter that certain classes, like for instance here, data access object, DAO, right, is used throughout the application in many, many different places. And we have utility objects like that. For instance, this data access object, student data access object, is used to find students, right, and return them as objects, right? Okay. And it's used in the student finder, some kind of a student finder, right? So we have the student finder used in our application as a separate object. So this just simple example hooks us on the dependency. Our course depends on the student finder, and the student finder depends on the student data access object. And we do this dependence very, very hardly, right? So basically, it is very tightly related dependence between these objects because we just hard-coded them over here, right? So imagine the application then, right? So application would look like that. At first, we need to initialize data access object, right? Then we have a finder. Then we pass this data access object to the finder. Then we have a course where we pass this finder inside, right? And now we can add to the course Martin Fowler. Then we can add Bill Gates, etc. Because then our finder just basically finds these guys. And this creates a very tightly related, tightly coupled classes. Once we want to change the finder, so for instance, finder or data access object would be looking into some different place. This is hard to do, right? This is quite hard to do because we have tightly coupled all these classes. Okay, so how do developers deal with that in the real world? At first, they start implementing some kind of the so-called service locator, because these data access object and finder, they are considered to be services, right? Services you are used throughout the application. So one of the possibilities is to use the singleton. So here is a singleton, right? And the singleton provides data access object and finder, right? So this is a singleton. And this is the application that uses the singleton to access this object, right? So everything is fine. We just have one copy of this guy, right, inside our Java virtual machine. And we just basically made it tightly coupled with the singleton. So now if we want to change that specific data access object in some place, right, we need to do that in the singleton, right? The problem with this simple implementation is that once we change it here, we change it for everybody, right? So this is not so nice. This is a segregated application interface example. I will not go through that because this is just a complication on top of the previously shown service locator, right? It has some additional abstract objects on top of these, right? These are dynamic service locators. Sometimes guys just think, developers think, okay, if I want to find various services throughout my application and make it dynamic, so why not to store them in the map, in the singleton map, right? Like here. So we basically access these objects by some name, right? So we basically get them by name. And it's a genius solution, right? So we basically pass that access object, we store it, right? And once we want to get it, we just basically access by the key. Yeah, I'm genius solution. So now it's always flexible, no ways of dealing with that and so on. This causes some problem because if you want to change it, right, for a certain place, you have to change it by the name. And the problem is that if you are running, for instance, in your as a developer machine and you access these students from the development database, you just do it like in one way, then you go into the integration, you do in another way. If you go into production, you do in another way, and so on. So you have to store multiple configurations. How to do that? This is not clear. So basically, this problem, I hope I have explained it at least a little bit for you, the dependency problem. So this dependency is being addressed by using so-called a dependency injection pattern, right? Okay, so dependency injection pattern is basically what it does, it reverses the problem, and now it basically says so that don't call us, right? Don't call like here for the specific object when you need it, but we will provide it beforehand for you. We will know what data access object you will need in this certain place, right? So we will provide it. We will inject you into this specific location. So this is inversion of control. So basically control is being given to the framework instead of actually calling from down below. It is provided from above. So this is like the Hollywood principle, right? Don't call us, we will call you, right? So when you have a script and you want this script to be put into some movie, right? And you tell that, please look into my script. What producers do, they just basically tell, don't call us, we will call you, right? usually, as I think, they don't call back. But this is the Hollywood principle in general, right? So what inversion of control or dependency injection does, it injects or provides needed dependencies to the object, right? And this basically what it provides for the developers, it provides an easy to work with framework, and it basically reduces dependencies in a code. Okay, so this kind of approach is used throughout the systems. It's very common now. Once now, in my team, we start to develop some Java applications. We usually define some dependency injection framework, and we use it throughout the application. If you have encountered with Spring, with Java Enterprise Edition, with Java JSF, with framework programming, MVC frameworks, etc., everywhere we have some kind of dependency injection used. Okay, so there is some link that you can read about this, about the good things to do that. Okay, so these are some dependency injection frameworks. There are some standards that have been put into the Java API. So basically, these are annotations that are used throughout the APIs, right? So basically, again, repeating myself, Java API defines interfaces and annotations, right? But it does not provide implementations. Implementations are provided by other frameworks. So these other frameworks could be, for instance, Juice. This is coming from Google, right? It can be Spring, it can be Pico framework, Excalibur, and Weld. I don't know which of them are alive still, but Juice certainly is, right? And this is a reference implementation, meaning that this is following all the standards that are basically defined in the specification of the Java. Okay, so how does it work, right? How does it work? We will look into the example, but in principle, Java x.inject package specifies a bunch of annotations. So one of the main of these annotations is so-called inject, right? So you can put this annotation, for instance, on the constructor. So here's.
I'm sorry, can I ask, please? Are you still sharing your screen? Because I cannot see anything. Only black screen.
Yes, it is. It's good for me.
It's good for everybody. Okay, there's something wrong with my screen.
How long was it happening for you?
I know, just suddenly just showing your
okay.
initial.
Let me stop and start again. Maybe it will solve the problem for you. Okay.
Yeah, now I see it.
Now it's
Thank
okay.
you.
Okay, good. Okay, not long. Okay, so let's hold on for a little bit. I will explain that. Okay, so basically, main annotation for the dependency injection is inject, obviously, right? And it is defined in the API. So, for instance, adding this to the constructor, it will automatically inject these arguments into the construction of an object. Let me explain how we'll do that. I will be back on this, right? But by annotating inject on the constructor, you expect that this engine is provided automatically for you by the configuration in the framework. And this private provider of seats, right, is a private field, and if it is annotated with inject, it will be automatically assigned with some value here, right? The Hollywood principle, the framework from top will provide this value for you, right? Just like these methods as well, right? It expects that these arguments are provided automatically. Okay, there are various additional annotations like the qualifiers, like the named, some additional names, some additional qualifiers. For instance, if you have a couple of seats as fields in your class and you want to be injected, you want to diversify these, right? You want a driver seat as a driver seat and you want a passenger seat as a different flavor of seat. So you basically specify what kind of the guy you want to be injected in this specific field. There are scopes, right, where I want this class to be acting. For one of the scopes, for instance, is a singleton. If you specify a class as being singleton, it will automatically be a singleton, only one instance in a system. So basically, this instance will be handled as a singleton, and everywhere where you expect this specific class to be injected, you will get exactly the same instance, right? So singleton pattern, you don't need to code the singleton. It will be automatically provided for you by the Hollywood producers, right? Okay, so providers, they provide a certain class. This is specifics. Okay, so I think we should skip that. We should go into the example. It will be easier to explain that. Let's take a look. This was the behavior, dependency injection demos. Let me find out how to show it correctly. This is the locator demo. Yeah, this is a locator as a singleton, right? Yeah. This is just an example. This is also far in the slides. Juice demo. Juice demo. Let me scroll a little bit. So, okay. Dependency injection demo. Okay, this one looks simpler. Right, this one looks simpler. Okay. Okay, so basically we have some service, right? So this is some service, a class, right? And we have another class. This is a test class, right? And inside on this test class, we just make an annotation, inject some service, right? We just tell that we would like for this class test, once we will initialize an instance, this some service to be provided by the Hollywood producers, right? From top. And now, once we construct our applications, we start from the juice. This is in mediator, an intermediate guy, right? Which will be providing us all the instances, right? So we just provide it a configuration. So this is the place where we can tweak, we can change what is actually provided. And now we have this injector guy, right? We have this injector guy. And from now on in our application, we do not initialize objects, new instances with the new keyword. We always refer to the injector, right? We always refer to the injector. And from this injector, we call get instance, right? Get instance. So basically injector.getInstance test class. And this get instance constructs the new instance of test for us and takes care of all the injections, right? So basically we dedicate creation of new objects from now on to this specific injector, to this specific framework. And for instance, now when we initialize this test one, right, as a separate object and we print it out, it will tell something about some service. So let's try running it, right? Let's try to run it. Okay, let's try running it and see this some service was injected for us. We did not make new some service. We just called it and it was automatically injected for us. So now when we just printed some service, it printed test, some service, and this is a hash, right? To string of some service. And as you can see, these are two different objects. So if some service is meant to be a singleton, let's remove this guy, right? So now if we run, we will have the same objects injected, right? As you can see, we have the same object injected. Even though we have two instances of test, now we have the same some service because we have annotated as being a singleton, okay? So this actually simplifies quite a bit of coding because now we don't need to inject various guys. These guys can be provided like that. If we want some class, for instance, let's create a class my factory, for instance, right? My factory. I want to have a factory. This is my factory, right? And I want to use it over here, right? In my constructor, public test, right? And my factory, my factory, right? Factory. Okay, this is my factory and I want to use that. So what I do, I just basically annotate it, right? With inject, yes. And now for this constructor, my factory will be automatic provided, right? I can print it out. Factory. Okay, so now it will be provided by the framework automatically, right? It just basically run file. And it, yep, provides. So as you can see, this is my factory and this is my factory, right? So factories were automatically provided into the constructor. Okay, so I guess you understood. So once you decided in your application to start using a dependency injection framework, Juice or Spring or whatever else, Weld, whatever, you from now on will start using it everywhere. So for instance, if you want here inside your application to use again create object, so you basically inject the injector, right? So for instance, like this, I basically do private injector, right? I pass this injector created over here in main and inject it, right? Inject. I basically inject it, and now in this toString, I can create a new one, right? Object, or here, for instance, I can use here I can't because this is a constructor. In the constructor, I don't have yet fields defined, right? Because this is by definition. At first, constructor is called when fields are being injected. So if I want to use injector in the constructor, I have to pass it over here. It's totally possible, right? So I would need to do this like that. Injector, right? And now I can use this injector over here on INSA method, etc. So all these guys are being taken care for me. Like for instance, system print injector dot, oh, it will be a recursive thing, right? A new instance, get instance, for instance, some service. This is a class need to be provided, right? Okay, again, the class, this is one file. This is a singleton, so we will get the same guy all over again, right? So this is my factory, this is singleton, and these are the singletons, and so on. Okay, I guess you understood the idea. In this Juice, yeah, it is basically the same like we had an example in the locator demo. So this is the same implementation by just using the injectors, right? Injector everywhere. Here we have a module, a little bit more elaborated example. Here we have a module, and this is basically the configuration for the injector. So now once you code your application, you write it down, you basically use these inject everywhere, right? You use these things and so on. And you want to change the configuration, for instance, to turn from development environment into the integration and then into the production, you basically need to modify just this module. It's very handy because this is a single place where the whole configuration of your application is, right? So basically you can check the host name, check the presence of some configuration files, read some configuration file and specify, right? Whatever you want to do here in this configuration part. And once you did that, you just basically rely on the injectors to provide all the required services for your application. Okay, I guess I'm done. I just have explained it. I hope I tried. I really tried. I did my best. I don't know if I'm succeeding or not. But we just finished the design patterns slide set, and I just tried to explain the classical ones and dependence injection, which I think is very important. And I encourage you to use service locator for your applications, whichever you use. If you're using a framework of some sort, like Spring or whatever else, I think you already do that. You already use these dependence injection frameworks. But even though you would be coding the application from the scratch, as you can see, it's very handy to start using the dependence injection framework. That's it for today, guys. Let me know if you have any questions. It was a long day for me, actually. I had a very long lecture before that. Okay, so let me go back again into the topics that we have left so far. So we have a concurrency. next week. Let me think if we should concurrency touch or change the order. Okay, let's not change the order. So basically, all of this concurrency, persistence, and functional programming are meant for the task number 3. Mostly, right? So I think we're quite good. We have quite good timing here. Okay, I don't see any questions. So if you have questions regarding tasks, you can stay some longer and ask me. If not, then have a nice week and talk to you next week. Stop recording.